Is section 2.5, exercise 54. And in this one, we're given, in this case, a circle, but we're given a curve that defines an implicit function, and we are supposed to find the equation for the tangent line and the normal line to the circle at each point. Now, the normal line, they say, is perpendicular to the tangent line. Okay, so we'll have to find a perpendicular to our tangent line, and I guess they give us two different points to work with. So we're given this circle about the origin, x squared plus y squared equals 36. Now this one, I'm going to do my implicit differentiation really fast and just say, well, I've got 2x plus 2y, y prime equals 0, because I've done it a few times already. So that gives me then y prime equals negative x over y. And the points they give me are the points 6, 0. Yep, that's definitely one. If x is 6, I get 36, and that works out. And then the other point they want me to do this with is 5 square root of 11. Okay, so let's do 6, 0 first. And, well, I've got the point. I just need the slope here. So y prime for 6, 0 is undefined. Right, I get minus 6 over 0, which is undefined, which means it's a vertical line in this case. And so for that vertical line, I know it goes through x equals 6, so that is just x equals 6, the line x equals 6. And we'll plot these in a moment. So here's 5 and the square root of 11. So in this case, y prime is equal to negative 5 over the square root of 11, whatever the heck that is. But that means my tangent line is y equals, and I use the point slope form, so that's my slope, m minus 5 over the square root of 11 times x minus 5 for my x0, and then plus my y0, so square root of 11. Okay, so let's go plot these things. Go back to Desmos. That's got a previous problem on it, so we'll get rid of that. And I put in my circle, x squared plus y squared equals 36. And so let's go here. There we go. And if you look at 6, 0, it does look like a vertical line. So, let's do x equals 6 that we saw. Yep, looks like a tangent line to me. And then next we do our line y equals, and we had what, minus 5 over the square root of 11, so I think minus 5 divided by the square root of 11, and then we come out of all that, and that's times, where's x? There's x minus 5, and then it was plus the square root of 11. Okay, so square root of 11. And that definitely looks like a tangent line, and if we look right there, that is the point 5 and 3.317. Well, let's check the square root of 11. 3.3166, I'd call that 3.317. Right, so, yep, there's our tangent line. I think we got this thing right. Okay, so I think that's what we were supposed to do for number 54. Right, find the equations for the tangent line. Oh, and the normal line. I forgot the normal line. So let's go back. Okay, normal line. Well, this was a vertical line, right? That's going up like that. So the normal line needs to be a horizontal line. Well, that's like y equals, well, what's the y value? 0. So y equals 0 for that one. And then here, the normal line, well, we have this line. Now, a line perpendicular to the slope, well, you know, that's that thing that the slope 1 times slope 2 is equal to -1, or, you know, m2 is equal to -1 over m1, the negative reciprocal. And so we need a slope of square root of 11 over 5 for that one. So y equals square root of 11 over 5. But the x and the y are the same thing. So x minus 5 plus the square root of 11. Okay. So let's go back here. And I would say, you know, here it's pretty obvious y equals 0, right? And toss that in there, y equals 0. Did I get that? No, what happened? I don't know. So try it again here. Y equals 0. Okay, there it is. All right, and what happened to our x equals 6? Did I, oh, maybe that's what happened. Did I get rid of our x equals, yeah, that's not good. There we go. So there is our x equals 6, and our, if I click on that one, our y equals 0. So, yep, those are perpendicular to each other. And then similarly, if I do a y equal, and this one was the square root of 11, and then come out here and divide by 5. And then we again had our x minus 5, so x minus 5 and plus the square root of 11. And there again, looks pretty perpendicular to me, and there we found our normal line. And notice that these normal lines go through the center of the circle. That's, you know, and that's kind of one way to define a circle. And so we get that nice picture. So there we go. That is number 54.